Hello and welcome to the Spatial Structures Movers and Shakers interview series as we look ahead to the IASS Annual Symposium and Spatial Structures Conference taking place at the University of Surrey in August 2021. My name is Mark Richardson and today I'm joined by Janusz Rębielak, who was Professor at the Faculty of Architecture of the Cracow University of Technology, Poland. Recently, Janusz was also Chair of Structures and Construction Engineering in the Institute of Building Design. As of a few months ago, Janusz has retired, but remains active in respect of the 2021 conference, where he is a member of the conference's scientific committee. Janusz, thanks so much for taking the time to join us today.
Mark, thank you very much for inviting me. It's a great honor to me to be here and to speak here.
Janusz, it's a fantastic privilege to have you on our interview series. Thank you for joining us. We begin by asking our guests about lockdown. How has the lockdown period been for you in Poland?
Like everywhere else, the pandemic took us by surprise and it has dramatically changed our lives. The adjustment to the remote work and study is really the big challenge to teachers as well as to students, particularly attending the universities in the current academic year. The remote teaching took me much more longer than usually before the COVID-19, and it has required more preparation of the necessary didactic materials. We all, I mean students and teachers, are looking forward to come back to the typical way of study, research, and participation in academic events, like for instance, attending the conferences and congresses. In my country, the number of COVID cases has been relatively low. We must follow the restrictions imposed by the government in order to protect ourselves and others. I know that this unusual situation will have for sure some long-term effects. However, I believe that in the end, the positive aspects will dominate.
Thanks, Janusz. And we're also asking our guests about their career journeys and their career paths. Maybe you can provide us with an overview of your own career journey to date.
Okay, I was born and grew up in a small town in Poland. Being the high school student, I dreamed of being a pilot, but due to the health reasons, it was impossible for me to fulfill this dream. I considered also to be an airplane designer engineer. The range of my interests was very wide. I liked art and history, as well as physics and mathematics. Moreover, I also liked to do the freehand drawings, and they were estimated quite high. That is why I decided to study architecture. In 1979, I graduated from the Faculty of Architecture at the Wrocław University of Technology in Poland. I got the PhD degree in 1982 in the Institute of Architecture and Town Planning at the Wrocław University of Technology. Title of my doctor's thesis was Shaping the Shell Forms by Applications of Modular Units. Professor Tadeusz Kolendowicz, who has given excellent lectures on theory of structures at this faculty, was the supervisor of my doctor's thesis. All the successive academic degrees, including the title of professor, I obtained at the same faculty and the same university where I have been employed until 2007. Recently as a head of the Division of Structures and Building Engineering. Since 2008, I was worked as a professor at the Faculty of Architecture of the Cracow University of Technology in the units which you just mentioned shortly before. In academic year 1984-1985, I worked as a research fellow at the Department of Architecture of the Delft University of Technology in the Netherlands, in the Division of Building Structures, together with Professor Beranek and Harry Koberman. In academic year 2001-2002, I was a visiting research fellow in Kawaguchi lab in the Institute of Industrial Science at the University of Tokyo in Japan. For more than 25 years, I cooperate with the Space Structures Research Center at the University of Surrey in the UK. I was also active as an architect. Previously, I managed also my own design office. I am a member of the advisory board of the International Society for the Interdisciplinary Study of Symmetry. I was also member of IASS and other international scientific societies. Since 2006, I am chairman of the Committee for Architecture and Town Planning of Wrocław branch of the Polish Academy of Sciences. I am also member of similar committee, National Committee of the Polish Academy of Sciences in Warsaw. I think that is all.
Excellent. That's really great, Janusz. Thank you for that overview. And we alluded there to the University of Surrey. Now, you've made contributions to several of the previous international conferences on spatial structures, including the 1993, 2002 and 2011 events held at the University of Surrey. Could you share with us any special or outstanding memories of these conferences?
Yes. So far, as you said, I participated in 3 international conferences of space structures organized by the University of Surrey. It was always very exciting for me to attend because I had the opportunity to meet personally the distinguished experts in all areas of spatial structures coming from all over the world. The most impressive to me was the attendance, the 4th conference organized in Guildford in 1993, because it was the first such a large and important scientific conference in which I participated. Moreover, I was a member of its international organizing committee, and in addition, I was rewarded in the proceedings by Professor Makowski. During this conference, I presented some proposals of applications of the space frames in the support structures of the roof covers, as well as in the main support structures of the tall buildings. The 5th conference was held in 2002, shortly after my research stay as a visiting research fellow at the Kawaguchi lab and at the University of Tokyo. During this conference, I presented 3 papers containing results of my present research in area of design, the tension strut domes, and the tall buildings. For the most recent conference held in 2011, I prepared only 1 paper, but I consider it as one of the most important of my research publications.
Excellent. Thank you very much for that, Janusz. Now, you alluded to the Kawaguchi labs there, and you have a notable working relationship with Kenichi Kawaguchi, who was a previous guest on the Movers and Shakers interview series. Could you tell us about your experience as a visiting research fellow at Kawaguchi's laboratory? What research projects did you work on together, and what was your experience of working in Tokyo?
As a result of the fellowship awarded to me in academic year 2001-2002 by the GSPS, it is the Japan Society for the Promotion of Science, it was possible for me to cooperate with Professor Kenichi Kawaguchi in his Shell and Spatial Structures Laboratory in the Institute of Industrial Science at the University of Tokyo. During this time, I had the opportunity to study his achievements, particularly in the field of the tense-grid systems design. I participated in almost all the research events at his laboratory at the University of Tokyo, as well as in seminars or conferences held in other cities in Japan. I highly respect Professor Kenichi Kawaguchi and share his opinions on numerous structural and morphological aspects of the design processes of various types of spatial structures. My research stay at his laboratory was very fruitful to me because its results have significantly enriched my perception of mathematical and morphologic requirements needed to be kept during the design process of very complex spatial structure. My cooperation with Professor Kenichi Kawaguchi has had an enormously positive impact on my academic work and forthcoming research, particularly regarding the shaping of the tension strat systems.
That's wonderful. Thank you very much, Janusz. We'll now move on to the middle section of our presentation, which is entitled Your Space, Your Structure. So I will hand over the presentation to Janusz, who will be presenting on a spatial structures topic of interest to him. So over to you, Janusz.
The general title of my presentation is Symmetry in Design and Analysis of Spatial Structures. After reviewing of all results of my research and professional activity, I came to the conclusion that the consideration of the basic rules of symmetry together with application of principle of superposition have always been present during the design processes carried out by myself in the field of shaping and analysis of various types of the spatial structures. In one of my first projects, I proposed a spherical form of the crystal space frame as the support structure of the dome, having an interesting exterior architectonic view and at the same time having an advantageous conditions of the daylighting of its inner space. 3 decades ago, the process of preparing a series of similar technical drawings took me several weeks. During this work, I studied morphological aspects of a very modern at this time structural system of the cable dome proposed by David Geiger. From this time, I had an idea how to design a similar system based on suitable transformation of spherical form of the just spoken space frame. Simplified scheme of the transformation is shown on the left-hand side of the slide. Because during the technical drawings take a lot of time, I have postponed the presentation of this structural idea until the time when I will be able to use an efficient computer-aided tool. As a result of my cooperation with the Space Structure Research Center at the University of Surrey, I have had an opportunity to study and to learn principles of the Formel's algebra and the programming language Formian, invented by Professor Hoshiyar Noshin and then developed also by his team. My ability to practical application of various functions of Formian has enormously enriched and accelerated my research and professional activity. This slide shows visualization of a numerical model of the same dome structure defined in Formian. Result of the mentioned transformations is shown on this drawing, presenting the basic shape of the crystal tension structure. This system, like the Geiger's cable dome, can be a structure of the dome cover of very large clear span and having very small rise, even equal to 0, which is considered as an advantage of such structures. The structural arrangement of components of this system was subjected to the further transformations, resulting in numerous new types of the dome tension structures. An example of one of them is shown on this slide. Tetrahedral modules are the important part of the structural system into spaces or a large group of these systems. The denotation of the structure is quite complicated, but I have chosen such system of denotations in order to reflect in their names the morphological order of each system. The spatial structure is also built of the tetrahedral modules spaced and alternately located over every second lower triangular area of the funicular truss and suitably connected together, as well as to the compression perimeter ring. The next group of such systems is created by application of the doubled form of the spatial hoops, and one example of it is presented on the slide. The vertex of the tetrahedral modules are joined together by the relatively long cables, and together with other tensile members, they create a huge double form of the concentric hoop. The huge double spatial hoops can be multiplied inside the inner area of the cover, like it is shown in this drawing. Due to the previously mentioned reasons, it can be the bearing structure of the roof cover having a huge clear span. The next group of structural systems is shaped by usage of the same type of the tetrahedral modules, arranged this time above and below the triangular hexagonal grid composed of struts located in the middle layer of the created spatial structure. Vertex nodes of these tetrahedrons can be connected in various ways. In my opinion, the structure VATH number 2 has a great development potential because the suitable arrangement of, for instance, the membrane sheets will give a very interesting architectonic form to the roof structure. That is why I propose the spherical geodesic shape of this system as the support structure of the central building of the previously designed new campus of my alma mater university. In the conceptual design, the building was intended as the testing object to carry out the long-term strength research and also testing of various types of the cladding systems. Support structures of the tall buildings can be also accounted to the wide family of the spatial structures. So far, I have proposed two types of the foundation structures. The structural concept of the final shape of the system, or of the system of composite foundation, is presented in the next slide. The point of the proposed technical solution is as follows. In a narrow space between two horizontally located beams is arranged an intermediate structural system which is connected to these beams by means of the structural nodes, being theoretically the articulated nodes or joints, and uniformly distributed along the neutral axis of the beams. Outer force is transmitted via the short vertical member and by means of the intermediate system to the structural nodes. The intermediate system is built of two subsystems. The first one is called a funicular system, and it is located below the neutral axis, while the second one is called an arch system, and it is placed below the neutral axis of these beams. When patterns of the both subsystems are symmetrical towards the neutral axis, and when they are combined together, they create then only vertical components of reactions act in the boundary areas. The loads can be applied in various symmetrical, eccentrical ways. Nodes of the type C1 and C2 mustn't be connected to the mother of the main beams of the structure. The lenticular form of the intermediate system placed between these two nodes is considered as the modular unit of the foundation. It can be repeated many times along the horizontal direction. Number of replication of the lenticular units is optional, what implies that the horizontal surface of this foundation can be theoretically unlimited. This structural system of composite foundation can be a base for various shapes of the mega structures. I have proposed this system of foundation as a structural base in the conceptual design of a megastructure called the Geodome Sky Towers, prepared for one of the architectonic competitions. The towers are of the height equals around 380 meters. The support base has form of a square. Its edge length equals around 250 meters. The geodesic sphere has diameter equal to 100 meters. I have proposed again the system as the base structure of an artificial island in the conceptual design entitled Ocean Agave, prepared for another issue of series of the architectonic competitions. It is designed as a floating structure in subtropical ocean areas in the far distance from the land, being a settling unit that is self-sufficient in terms of energy and food supply, and be able to house a group of around 150 persons. The circular form platform of the Ocean Agave has slightly more than 400 meters. Spatial modules of this system of composite foundation can be made as a huge waterproof boxes having substantial uplift pressure. That is why they could be the component parts of an artificial island able to float on a lake or on a sea. Taking into consideration the basic rules of symmetry is also very helpful in the methods of static calculations. During my research stay at the Delft University of Technology, I have got a task to do an initial static analysis of one of the tension structures proposed in my doctoral thesis. Beforehand, I was required to do a physical model of it. The static scheme of the left-hand side of this slide shows a simplified cross-section of the structure, and it represents the fourfold statically indeterminate tension truss. When that system is overloaded, the four members of the top cord are slackened, what implies that they are excluded from the force transmission. Therefore, the scheme of the overloaded structure shown on the right side hand represents a statically determinate truss or system. Number of the excluded tension members equals 4, and it is equal to the statically indeterminacy of the basic truss system. This observation arises a following question. Is it possible to calculate in 2 stages such complex truss by help of method applied only for calculation of the statically determinate systems? Answer for the question is presented on this slide. In the first stage, one should remove a number of members equal to the statically indeterminacy from the top chord of the basic truss, what gives in the result the truss having scheme shown on in the central set of the schemes of diagrams. That form of the statically determinate truss has to be loaded by the forces having half values of the load forces applied to the basic truss. A very similar procedure has to be done in the second stage. In each stage, One can use, for instance, the Cremonese or the Ricter's method. Because these methods don't take into consideration the stiffness differences between members, that is why the just presented two-stage method may give in the result only the approximate values of forces. The final values of these forces acting in members of the basic truss will be the resultants of values of forces detected in each stage in members having the counterpart positions in the statically determinate trusses. It is dictated by the principle of superposition and rules of the calculus of vectors. The differences between the force values calculated in the same truss members by the application of these two different methods are rather small. From comparative analysis of the results obtained in both the calculation methods, follows that the two-stage method can be applied as an approximate method of calculations of the statically indeterminate trusses. As I have previously pointed out, I apply fermion in all fields of my research and professional activity. I am still an aviation enthusiast, being a participant of series of special scientific conferences. I was encouraged to present a structural concept of an airplane, which I initially designed in my youth. The main purpose of the proposed structure was striving after getting an airplane having a large range of the flight speed, in particular of high cruising speed, by an airplane equipped with propulsion of relatively low power. In the next few slides, the structural concept of it is presented. You can notice that, in fact, only the nose of the airplane can be rotated. Now, being retired and having more free time than before, I plan to finish working out the new structural concepts of the airplanes. I believe they could be useful. Of course, they will be symmetrical, and for sure, I will apply fermion for defining numerical models of them. I hope that after this presentation, you can share even partly my opinion that the simple rules of symmetry, together with the principle of superposition, have always been very helpful in the fascinating process of shaping, design, and analysis of the spatial structures.
Thanks very much, Janusz, for taking us through your presentation there. Really fascinating insight into your work and research. Very much appreciated. Moving on to the final section of our interview, we look ahead to the future of spatial structures, and in particular to the 2021 conference. Now, a key theme of the 2021 conference is inspiring the next generation. What advice would you offer to aspiring engineers looking to enter the field of spatial structures?
The attendance of the forthcoming conference will be an exciting, important, and inspiring event, especially for young architects and engineers. In general, my advice is very simple. You should constantly study the previous and the present stage of knowledge in this field. Apart from using the sophisticated computer software and numerical techniques, you should always verify your assumptions on the analysis of even very simple physical models. Please do not strive after the unique, expressive, of extraordinary spectacular architectonic forms of the buildings, whatever the cost. The equally interesting aesthetic effects can be obtained by application of rational, effective way of thinking based on inspiration coming from observation of nature, and of course by application of simple rules of the theory of structures.
That's great. Thank you, Janusz. And like several of our guests on the Movers and Shakers interview series, you have a background in architecture with research interests in engineering. How have you found the interplay between these two disciplines, and what inspired you to get into an interdisciplinary field?
Architects and engineers always played a significant role in the investment processes. The success of the project is conditioned by the effective cooperation between them based on mutual understanding, respect, and support for each other. Architects and engineers are equally important at each stage of the design process. We should strive after getting the most effective solutions, mainly in terms of material and energy consumption, because we are also responsible for protection of resources of our planet for the next generations.
Thank you, Janusz. Some very pertinent points there. We've reached the end of our interview, but thank you very much for taking the time to speak to us today. It was fascinating to hear about your work and research. To those watching our video series, don't forget to follow the 2021 conference on social media. Links to our accounts across social channels are included in the description section of this video. But for now, Janusz, thank you for talking to us today on the Movers and Shakers interview series, and hopefully we can catch up with you again as we move closer to the 2021 conference. But for now, all the best and speak to you soon.
Once more, thank you for the invitation. Thank you very much.
Bye, Janusz. See you soon.
Yeah.